subscribe.
Hey y'all, welcome back. So today we have been introduced to this idea of a limit, and so we're going to be answering many questions about limits, whether they're just kind of the overall limit or the left hand versus the right hand limit. So let's go through this, and first we'll answer some limit questions based on this graph. So if we want the limit as x approaches 0, first we need to make sure that this limit actually exists. And in order for the limit to exist, both the left-hand limit and the right-hand limit at 0 need to exist. So if I look at here at the graph, here's where x equals 0. You can see that the left-hand part of the graph is approaching the same value that the right-hand is. So the left-hand limit is 3, the right-hand limit is 3, so that means the limit itself is going to be 3. So as long as the function is continuous, at that point, you can just evaluate, in this case, f of 0, which is 3. For part B, when you see a little minus sign in the top right corner here, that means we're only evaluating the left-hand limit, so we don't even need to look at the right-hand limit. If you see the plus, like on C, that means we're looking at the right-hand limit. So just make a little note here that this is the left-hand limit. Okay, and if you see the plus, that is the right-hand limit. So if we look to see what the value of the function is approaching as you approach 1 from the left, here's 1, and you see we have this break here. We've got this discontinuity. But if we're only focused on what's going on to the left of that point, we can see that we are approaching what looks to be about, see, 4 is here, looks about like 3.5. So I'm actually gonna say it's approximately 3.5 because I'm not sure exactly. And this piece of the function is not super well defined, so it's not like we could figure out an equation to plug it into. And just estimating is okay if it's not super clear like that. Now if we approach 1 from the right, so in other words, if we kind of follow the graph from the right-hand side, we're approaching y equals 1. So because the left-hand limit when x approaches 1 is different from the right-hand limit as x approaches 1, that means the overall limit as x approaches 1 is not defined. Okay, so we're basically going to say that it does not exist. Now if we just evaluate the function when x is 1, and we're not talking about limits at all for part E, we just need to figure out where it is actually defined when x is 1. And if I look for x is 1, it's defined right here, and y is going to be 2. For part F, it says find the limit as x approaches 4. Now even though it's undefined at 4, so we can actually answer part G there, it's not actually defined at 4. But the value of the function at x equals 4 is not going to give you the limit unless it's continuous. So it's not continuous here at 4. We have a little break, a little hole in the graph. So all we're going to be looking at is the left and right hand limits, and if those two agree, then that'll be what the limit is. So you can see that the left hand limit is approaching this value where the hole is, y equals 2. And if I do the same thing but from the right, I'm also approaching y equals 2. So the limit as x approaches 4 is 2, but the value of the function at x equals 4 is undefined, or it does not have a value. All right, let's take a look at number 2. So we got another piecewise function, the 1, 2, 3, 4, 5 pieces, 6 if you include this singular point. Well, I guess we would need to. So let's go ahead and start answering these limit questions. So as x approaches -2, we can see from the left-hand side it's approaching negative infinity. From the right-hand side it's approaching positive infinity. Those do not agree, so we're going to say it doesn't exist. Part B says the limit as x approaches 0. Now from the left we're approaching what looks like to be about a half, but from the right we're approaching 4. So since those two do not agree, we have another one that does not exist. As x approaches 2, even though the function's undefined there, the value is approaching what looks like about a half. And this is going to be another one where we have to estimate. From the right, it's also approaching 1/2. So I'm going to say that the limit here is approximately, because we don't know the explicit equation here, so we're not going to be able to say exactly what it is, but it does appear that it is about 1/2. For part D, we're approaching 0 from the right. Okay, so we already said that there was no limit as x approaches 0, but that was because the left-hand limit and the right-hand limit didn't agree. This is asking for specifically the right-hand limit. So, in other words, what is the graph trending towards as we approach from the right? And it's approaching y = 4. The value of the function when x is 0 is going to be this closed dot right here, so that's also going to be 4. Now if we substitute 2 into the function, we can see that there's no value here. We have a hole. So g of 2 is going to be undefined. G of 4 is defined. It's just a single point here. So like if we wanted the limit as x approaches 4, that would not, I guess we would say infinity if we do have like a vertical asymptote going on here. But at 4, we've got this sort of singular point just hanging out there, so the value of the function is actually 2. All right, let's take a look at number 3. It says let f be the function defined by the absolute value of x over x. So let's try to get an idea of what this thing actually looks like. So here's my x values. I'm better off just typing this. My f of x. Not sure what happened to my table there, but let's do this. Okay, this is really just to get an idea of what the graph is going to look like. So as we pick numbers, and I'll just pick like -2, -1, 0, 1, 2, and let's see what this thing is going to actually equal. All right, so if we substitute these numbers in, it won't take too long for you to figure out what's happening here. If I plug in -2, I get the absolute value of -2 is just 2, and 2 divided by -2 is going to be -1. And that's going to be what I get every time I plug in a negative number, because any negative number that I plug in here is going to make this positive, and this is going to stay negative, and they'll be the same like absolute value. So we're going to get -1 for all negative values of x. If the number we're plugging in is positive, then we're going to get a +1, because then the absolute value doesn't really do anything. So like 1 over 1 is 1, 2 over 2 is 1, 3 over 3, and so forth. So all of the positive values will just give you x equals 1 or y equals 1. And then at 0, it's undefined because we cannot divide by 0. So if we're trying to think about what this graph is going to look like, basically we're going to have, here's where -1 is. Here's where +1 is. We're going to have an open circle up here and down here, and have a horizontal line going from the left along -1 and going towards the right at +1. So this is what the graph looks like. So if I want to write a piecewise function for this, I can say that f of x is going to equal, and then show my little set bracket here. And then so it'll equal for the top section, or I guess let's start with the negative x values. It'll be -1 for when x is less than 0. And it'll be +1 when x is greater than 0. So this piecewise function is actually equivalent to that absolute value function above. So you know, whether or not you write the function using this piecewise format or you write it like up here, it means the same thing. Now if I want the limit as x approaches 0, we have a problem because the left-hand limit is -1, the right-hand limit is +1. It's not continuous here, but we do have a break. We got a little jump in the graph, So this one is just not going to exist. All right, let's move on to page 2. So we've got this piecewise function defined using a and an absolute value. First it says sketch the graph. So the first part, so I'm just going to do a quick sketch, and then the x minus 1 is going to be the absolute value function. So it's going to be like this V-shaped, but shifted over to the right 1. It's going to look something like this. Okay, so the value of g of 0 is just going to be, this you can get just straight from the equation. We would want to plug it into the top, not that it matters, but we would want to plug it into the top expression versus the bottom, because that's where x is equal to 0. So we would say that this equals, oh, it is 2. Yeah, I already typed that in. Okay, so that's kind of weird. Okay, so now if I want to find the limit as x approaches 0 from the right and from the left, and just remember, when you see that plus, that's going to be the right-hand limit. So from the right, and then if you see the minus in the top right corner of that number, that's telling you to find the limit from the left. So if I follow the graph from the right, basically walking along this absolute value function, as I get closer to 0, the value or the y value of the function is approaching 1. So I would say that the limit, what if I can, does this have a limit? Yeah, it does. Oh, awesome. So the limit as x approaches 0 from the, let's see here. I guess I can do this. From the right is going to be equal to, or of g of x is going to be equal to 1. And then if we approach it from the left, it's going to equal 2. If I follow this graph from the left-hand side and I approach x equals 0, the y value is approaching 2. So since these two things are not the same, since the right-hand limit and the left-hand limit don't agree, then the overall limit we say is not defined. So we say it does not exist. And so the reason being the left-hand limits and the right-hand limits are not equal. Okay, so let's go down here. We've got 2 more questions left. Number 5, it says write a piecewise function to where f of 2 is 2. So let's just start with that. So what I'm going to do first is try to sketch it out so we can get an idea of what it should look like, and then we'll write the function. So when x is 2, y has to be 2. Okay, so that's defined by that first piece. So we've got this point 2, 2 here. Okay, it says if we approach 2 from the right, then our function is approaching 3. So there's a lot of different ways that you could draw that. Basically, you could do whatever you want over here as long as you kind of end up at 3. So I think probably the easiest way to do this is just to create a constant function. Just draw a horizontal line. It doesn't have to be a horizontal line, but as long as you got this point right here on the right-hand side and the function's continuous after that, you could do any number of things. You can do something like this, as long as you can write the equation. But I think the easiest equation to write is just a constant. Okay, so as I approach x equals 2 from the right, this is approaching 3. So I've already satisfied this one, and I've satisfied that one. And so now I need to satisfy the last one, which is the limit as x approaches 2 from the left. The y value needs to be 1. So in other words, we should have an open circle down here at 1. So we could draw this any which way. We could do a parabola, we could do a line, but again, I think the easiest way to go here is just to do a horizontal line. Okay, but just know that your answers may vary here. Okay, you can draw those different pieces in different ways. But let's go ahead and write the function now. I'm going to say f of x equals, and we are going to split this up into 3 parts. So and this will depend on how you drew it, but the way I drew it was with those constant pieces. So I'm going to say that it equals positive 1 when x is less than 2, and it equals 2 when x equals 2, and it'll equal 3 when x is greater than 2. So we've satisfied the first condition, the second condition, and we satisfy the third condition. Now we've got one last question here. So for number 6, this last problem, we're just trying to determine whether or not these statements are true or false based on this piecewise function that's given over to the right. And it really just has to do with evaluating these limits. So what we'll do is we'll just see, like, if we want to know if this is equal to this, what we can do is just calculate both and see if they're the same. So like for the first one, it says the limit as x approaches 2 from the left. So if we approach 2 from the left, we can see that the limit is approaching -1. Okay, so this one's -1, and f of 2 is also -1. That's where the point is filled in, where we get that closed circle. So this one works. This one is going to be a true statement. For part 2, we're comparing the left and the right hand limits when x approaches 6. So if I'm looking at 6, you know, I'm approaching 6 from the left, and I'm approaching -1. Approaching 6 from the right also approaches -1. So this is going to be basically the same thing, right? It's just kind of coincidence that these things equal the same, but yeah, -1 does equal -1, so this is another true statement. So yeah, for this last one, we've got the limit as x approaches 6, and since we already found that the two right and the right hand and the left hand limits both agreed, so this does exist and it does equal -1. However, even though this one equals -1, f of 6 equals -3. So a real important point to make here is that the limit of a function as x approaches a certain value does not necessarily equal the value of the function at that x value. So we see, like, these do not equal, and so this is going to be a false statement, so we're not going to include this in our answers. Only number 1 and number 2 are going to be true. So that's it for tonight's homework. Let me know if you guys have any questions. And other than that, y'all have a great day.